start recording. You want to really work on for all day today, really work really hard, right? And just spend the time and understanding all the materials. Okay? So far, so good. Any question? Okay. Thank you. All right, so without further ado, let me actually start sharing my screen. Okay. Oh no, before we actually go on, is there any question of understanding? Is there, oh, like Brooklyn said, I got a lot of questions. No. Is there any question on yesterday's material, like the last night's material about the hypothesis testing?
Yeah, I have a question. I need to get it out, but I have a question about the notes homework, the one where we had to go over the examples or something like that.
Notes homework. Let me just see. Let me see here. Am I sharing? Notes homework. Notes homework. Let's see. Notes. No, that's not it.
The hypothesis test for mean class notes.
Oh, mean class notes. I was gonna do proportion, but yeah, I'll do both, right? So I did 2 of this already. I'm gonna do a 3rd one today, okay, for you guys. I'm gonna go do it by step-by-step process, okay? Before, let me actually give you an overview, right? So what is an overview of hypothesis testing? Can someone actually kind of summarize what hypothesis testing is all about? Anyone here? For MVP point? Come on, just a little bit of information. What is hypothesis testing?
I think it's rejecting a claim or not rejecting a claim based on the information.
Very good. That's all it is. Testing your claim, right? Testing your claim, okay? So how to test it? We test it using what we call data, okay? So we gather data information in order to test our claim, okay? All right. Suppose, say, Hugo. Okay. Suppose Hugo's actually a basketball player. What sport do you play?
Sorry?
What sports do you play?
Soccer.
Soccer. But suppose that he plays basketball, right? Okay. And this is Hugo. Okay. And I love playing basketball. And I say Hugo and I grew up each other, right? Okay. Around each other, and then I always see Hugo when he was little and say, you know, I always play with them. Professor, yeah, I know how you play. You suck at basketball. You know, your free throw sucks, right? And then he's like, yeah, but I tell him, you know, I moved away and then I've been practicing a lot. It's gotten a lot better, I tell Hugo, right? Okay? And then Hugo goes, I know you only hit your free throws about 40% of the time. So Hugo says, Hugo says that, oh, I suck. I really suck at basketball. Your free throw shooting is about 40%, right? 0.40. And I say, oh, I'm claiming it's gotten a lot better. I've been practicing, you know? Every night I've been shooting free throw maybe 100 times a day, right? Every night, right? And then it's gotten better. What do you mean by better? It's gotten better than 40%. Okay, that's my claim, right? That's your null hypothesis is always equal to alternate hypothesis. You have cases we have less than, greater than, or not equal to. For my case, it has improved, right? Greater than. So these are some keywords you want to identify with alternate hypothesis. That's my claim. Me, I'm like, oh, I've been shooting a lot of free throws. Right? Like every day, every night, I've been shooting 100 free throws. And then he goes like, BS. You know, I don't believe you. I know you. You suck, right? And then you go, prove it, right? So I say, okay. So Brooklyn, what would I do to prove to him that I actually shoot better than 40% free throw?
Like improve your.
No, go out and show him, right?
Yeah.
And shoot some free throw. Okay, I go out. I made 3 out of 4 free throw. Oh, come on. I made 3 out of 4 free throws. Okay, what is that? Cameron, what's 3 out of 4? What percentage is that?
75.
75%. Is that sufficient to prove that I actually shoot 40% or better?
Yes.
Really? Oh,
You
thank you for trusting me, right? But what would you say, Hugo?
I would say you have to shoot more free throws to get them more.
Oh, you're like, 4 free throws is not enough, right? That doesn't prove me anything, right? You got a lucky shot, right? Okay, maybe it was just your day, right? Okay, 4 free throws. Nah, that's not gonna tell me enough information, right? I want you to shoot more free throws, right? Okay, if I shot 100 and if I made over 40, right? Then you could say, oh, okay, I can see that you can actually, your free throw has gotten better, right? Okay, that's enough evidence, right? But with 4, it's not enough evidence, right? Even though I shot here, okay, not enough evidence to actually prove to me that I actually improved. So far, so good. That's basically the overview of what we're trying to do. Okay, so far, so good. Does that give you an overview of what hypothesis test is all about? Testing the claim. And how do you test the claim? By gathering data, right? Is that significant enough, right? And how do you test that it is significant? And we'll mathematically test the significance. Okay, how it is significant. So far, so good? Okay, any question? Okay, so now we know that hypothesis test, you have 3 parameters that we are going to be dealing with. We're going to be dealing with proportion, mean, and standard deviation. Okay, there's 2 types of claims. Okay, we have null hypothesis and alternate hypothesis. Null hypothesis is the value of no change. You're like, oh no, you haven't improved. You stayed exactly the same as before, right? Okay, so no change whatsoever. Null is no change. It is a value of parameter set before we run the test. Basically, like I know you, how you play, right? You play exactly the same, right? Your free throw shooting hasn't really changed all that much, right? Okay. Usually it is the value obtained from previous report because you already knew me, say, we play basketball together, Hugo, right? So null hypothesis is always the same, right? Always equal sign, okay? So I highlighted that. Alternate hypothesis is the relationship between the parameter and the given value we are testing. Okay, is it less, more, or different? Less, more, or different. Okay, so the keywords that we're going to be using a lot of the time: has it decreased, less than, has it gone down, improved, increased, is it greater than, for greater than, or greater than or equal to, has it changed, is it different, right? Those are the keyword that is not equal to. So alternate hypothesis, the only thing that changes, is it greater than, or is it less than, or not equal to, right? So far, so good, okay? And so forth, okay? And these are, right, your null alternate hypothesis for population, or the proportion, mean, and standard deviation. Tip, don't try to memorize this table, right? Okay. Just focus on the 3 things here. What is the same on every cell, right? What's the same on every cell? You notice that the null hypothesis is always what? Always equal to. You notice that. Null hypothesis is always equal to. Doesn't matter if it's mean, proportion, or standard deviation, right? Okay, always equal to. Okay, what is all the same? Look at the individual row. Okay, all right, so let me, how do I mute? Let me mute.
All right, I muted all, Professor. So you'd have to unmute yourself.
Okay, all right. It's good? Can you guys all hear me?
Yeah, there's no feedback now.
Okay, all right, good. All right, look at the individual row. What is the common throughout the individual row? Individual row common is that you have less than, so we have common, we have null and alternate hypothesis, right? For everything here. And then we have less than, greater than, or not equal to for all of them here. And then individual column, these are all less than for alternate hypothesis, greater than for all alternate hypothesis here. And then we have the not equal to for all alternate hypothesis, right? Okay, those are the three cases. Alternate hypothesis, you have three cases: less than, greater than, or not equal to. Okay, so when we deal with alternate hypothesis, or HA, it could be left tail, right tail, two tail. We're not going to put heavy emphasis on this because we're going to be using a lot of stack crunch. Okay, if you aren't using stack crunch, I actually have you draw the normal distribution and indicate where you are here and figuring out the p-value for all of this. Okay, using the normal distribution table here. Okay, but we're not going to be doing that. Okay, so what is hypothesis testing really? Again, I told you the overview. Assume that null hypothesis is always true. Just like in the courtroom, right? It, like the assumption of, in the courtroom, the defendant is always what? Always innocent until what?
Proven guilty.
Proven guilty. So therefore, we gotta prove that the person is, the defendant is guilty. As a prosecutor or as a statistician, we wanna prove otherwise, right? Something different, the guilty portion, right? So far, so good? Okay, and then number two, we want to collect the sample data and calculate the corresponding statistic. We call that the test statistic, right? Number three, find the conditional probability getting the sample, right? And so forth. Is that p-value, whatever the probability directly address the question of variability, is the variation something you want to expect if the null hypothesis is true, or appears as though something unusual has occurred, right? Unusual means, is there enough evidence, and so forth. If this conditional probability is too low, i.e. the variation from the null hypothesis appears to be significant, then we reject the null hypothesis and support the alternate hypothesis, okay? And so forth. Okay, let me give you another analogy here. Okay, there's been a crime scene here. Okay, there's a crime scene. There's a person. Oh, Brooklyn, were you there last night?
No, I couldn't go last night.
Oh, who was there last night? Oh, no one here. Okay, good. You guys never heard of this. This is good. Okay, this is not the second time around. So here, there is a crime scene here. Okay, and I caught this suspect, or the police caught this suspect. Okay, the suspect is always what? Your null hypothesis in this case is the defendant. In this case, the defendant is what? Null hypothesis, right? Suspect is what? Okay, in a courtroom, without a trial, the suspect is considered to be what? Assumed to be what?
Innocent until proven guilty.
Innocent. So suspect is innocent. And we're trying to claim that innocence until proven guilty. Innocent, right? So suspect is equal to innocent. Suspect not equal to innocent, not innocent, right? Which means guilty, right? Which means guilty, right? So far, so good, right? So that's the claim. Null hypothesis always equal to innocence, equal to, right? Okay, so here, this is the crime scene, okay? The suspect that I caught has no relationship whatsoever. He does not live in the area that the murder victim, right, is in, right, and has never met the murder victim, has no relationship whatsoever. Okay, what's the probability that he actually killed this person? Do you know? You don't know, right? But what if they found a hair that's here? Okay, what's the probability that his DNA, the suspect's DNA, is in the crime scene if there is no relationship, they never met before, right? What will be the percentage? What's the probability that his DNA is in the crime scene? Ian, if I ask you, what will be the probability that his DNA will be in the crime scene?
Like if his hair was there?
Yeah, like they found a hair there, right?
Probably like probably
He has
like,
no relationship whatsoever.
but if they found a hair, probably like
No. Say, what's the probability? It doesn't matter if it's hair or whatever. What's the probability? So if he was a suspect, right? Okay. And he's like, I did not commit the crime. What are you talking about, right? I did not commit the crime, right? But we found the DNA. What's the probability that his DNA will be in that crime scene? All right, Alex, what's the probability that his DNA will be in that crime scene?
50-50 chance, no?
No, he has no relationship, never even met the guy.
So then it
a
won't be like
0%
zero.
chance.
0%, yeah. His DNA is not going to be in the crime scene. He never even met the guy, right?
Well, he never met him, but he probably did something to him. Well,
You don't know. We haven't actually proven to him, right?
Well, the hair is not his, right? Is that what you're saying?
Not yet. We don't know. Suppose. So let me just ask. So let's not say hair. We didn't find anything, right? We'll just say, what's the probability that even though he's considered to be a suspect, right? What is the probability that his DNA will be found in that crime scene? What's the probability? 0, right? If he has no relationship, never even met the guy, doesn't live around him, right? There is going to be no chance that his DNA will be in that crime scene, right? So far, so good? 0 chance whatsoever, right? 0% chance that his DNA will be in that crime scene. Now, what if they found a hair? His hair. That's his hair in the crime scene. Is that a significant evidence, Cameron? Is that significant?
If he's still claiming that he ain't never met the dude, but his hair was there.
Yeah.
I'm gonna go, yeah, it's a little shady, but like it's not enough to convict.
But it's a little shady? No. Say, look, Cameron, I don't know. I mean, I know you, right? I met you, right, through Zoom, right? And somehow you died, right? What's the probability that my hair is going to be in your room?
None.
None whatsoever. Even though I actually know who you are, right? I don't know exactly where you live, where you right? But if my hair is actually found in your room, then they could say that, oh, why is my hair in your room, right? When you're actually killed, right? That's interesting, right? Isn't that a significant evidence? Yes? Cameron, where are you? Can I see you, Cameron? Where are you? Where are you? I can see barely any. Okay. So, yes or no?
Yes.
Yeah. So if I find he has no relation, this suspect has no relationship whatsoever, never even met the guy, right? And doesn't even live around him, and I found his hair in that crime scene, that hair is a very significant evidence to conclude that he actually did the crime, right? It's significant enough to convict the person, right? Yes? So far, so good? It's not just by coincidence, because he wasn't driving by over there or anything like that. Okay, now let me give you a different scenario. This suspect is actually what? The wife. And this is the husband. Okay. So far, so good? Okay. Now, what's the chance that they'll find her DNA in that crime scene?
100%. She lived there.
Yeah, she lives there. Is that finding her hair or the DNA in that crime scene, is that significant?
No.
Yep.
No, it's not significant.
Actually, no, it's not.
Yeah, it's not significant. Why?
Because she lived there.
Because she lived there, yeah.
That's his wife, right? Okay, they've been living there. Her DNA is like everywhere, 100% of the time in that house, right? So by finding her hair in there is not significant whatsoever. Okay, get the idea what is significant and what is not a significant evidence, right? Okay, so therefore, in statistics, we call, and I think I wasted a lot of time just explaining the significant way too long. We call this the p-value. Okay, if you have remember, right? If this wasn't a wife and this was a complete stranger, right? Having his DNA in this crime scene, like hair, right? In this crime scene is very, very low. And if we did find it, right? And if we did find that DNA, his DNA in that, then we could actually say that that is a very significant evidence to convict that. That's basically the idea of p-value. If your p-value is smaller than the significance level alpha, then we can actually convict them. Okay, then we reject null hypothesis. Okay, if this is considered to be, if the suspect was considered to be the wife of the husband here, right? Your p-value, having DNA found in that, right? In that room right there, or in that house, right? Your p-value, the probability of finding her DNA is very, very high, okay? Bigger than the significance level, okay? Which is your alpha level. So therefore, you do not reject null hypothesis, okay? You do not reject null hypothesis, okay? Of course, there's gonna be, right, cases where we could what? Go wrong. What do I mean go wrong? It is possible, right, it is possible, okay, that if this person, say this wasn't a complete stranger, right? If this was a complete stranger and they found his evidence and he truly did not actually commit the crime, but he found the evidence here, his DNA, and he was convicted of the crime, then that's an error, right? That's a mistrial. Get the idea? And that's considered to be your type 1 error. Okay? Type 1 error. When you reject the true null hypothesis, is considered to be type 1 error. The probability of making that type 1 error is considered to be your significance level, alpha level. Okay? That type 1 error is considered to be alpha level, right? Okay? Of course, there are cases. So you have innocent person actually going to jail, right? That's considered to be your type 1 error. There's another case where there's actually truly a guilty person that gets off scot-free, right? Okay, there is a person who actually committed the crime, but the police wasn't able to find enough evidence to convict the person of that crime, and he gets off free, and that's what we consider to be a type 2 error. Okay, and we usually call the beta. Okay, so we don't look at the beta all that much. We look at the alpha. That's your significance level. Okay, so far so good. All right, without further ado, let me actually do an example problem so that you understand exactly what we're trying to do here. Okay, let's do the last here. Okay, so let me have you read here. So basically, we're going to be following the 4-step or 5-step process here. Okay, so state number 1, state your null and alternate hypothesis. Okay, step number 2, identify your significance level. Step number 3, calculate your test statistic. Step number 4, find the p-value. And step number 4, find the p-value and your conclusion. So this right here is, I think, conclusion. So this right here, we write our conclusion are going to be our 5th step, basic idea. Okay, but always we have to, before we do anything, your central limit theorem has to be met. Okay, which means that we know that this is normally distributed, so that we could use a normal distribution to calculate our probability. Okay, so far so good. Okay, so let's go through this right here. So in August 2003, 56% of employed adults, so let me erase this right here, employed adults in the United States, right, reported the basic mathematics skill were critical to their job. Okay, supervisors of the job placement office at a college thinks that this percentage has what? Decrease due to the use of technology in the workplace. Okay, he asked a random sample of 480 employee adult and finds that 297 of them feel the basic mathematics skills are critical to their job. Is there sufficient evidence to conclude that the percentage of employee who feels the basic mathematics skills are critical to their job has what? Decreased at the 5% significance level. Okay, at the 5% significance level. So without further ado, let's actually go through all these steps here. Okay, first of all, right, what we want to do, just like we did over here, what's the parameter that are we working with? Okay, what's the parameter? What are we working with? Mean, proportion, or standard deviation?
Proportion.
Proportion, good. Okay, so far so good. What are we observing here? What's your observational unit? What's your observational unit? Who are we observing?
Percentage of employed adults. Yeah.
The
More
employees,
specific.
the ones who say that they need math in their job.
So we are observing 400 employee adults, right? 480 employee adults, right? Oops. Okay, so far so good. What is our variable? What vary? What is our variable here? What's
Adults
changing?
that reported basic math skills were critical to their jobs.
More specifically, good. Percentage of adults, right? Okay, percentage. Okay, so far so good. Okay, any question? So far so good. All right, so now we want to define what our parameter, what are we dealing with, observational unit and the variable. Now let's collect our data, right? So here, X, okay, which is what we consider to be a number of success, right? Okay, number of success. What do you mean by number of success? Okay, so how many employees said that they feel that the basic skills were critical to their job? How many feel?
297.
297, very good. Okay, and N, what is the number of observation or number of sample that we take?
480.
480, very good. So there are 480 adults here, right? They sample all together. So therefore, what is our p hat? We can calculate that. Sample proportion. If we put that into a calculator, 297 divided by 480, which gives you approximately, we'll say 0.6, we'll do that, 1875. Okay, so far so good. Any question? Okay, now what is our P? Okay, population proportion. What's our P?
0.56.
0.56, very good. What is our Q? It's complement.
0.44.
0.44, very good. Okay. Now, once we gather the data, okay, we have to kind of see that we meet the central limit theorem before we do anything. We'll go on to hypothesis then. If it doesn't meet the central limit theorem, then we don't even have to do the hypothesis testing because it doesn't meet the central limit theorem. Okay, so does it meet the central limit theorem? CLT. Okay. Number one, is it simple random sample? Yes or no? Yes or no?
Yes.
He takes a random sample of what? 480. Oh, look at that. It says SRS, right? Simple random sample. It meets condition number one. Okay. It's random and independent. Okay. Number two, do we have large enough sample? Yes or no? Was N times Q? Was, oh, I'm sorry, N times P? And when was N times Q? So N times P is 480 times 0.56, 480, 0.44. I think they are much bigger than what? 10, right? If you calculate it, I'm not going to do that. I know it's going to be bigger than, because 50% of 480 is 240. I can automatically say that's much bigger than 10, right? 480, 40% of 480, right? 40% of 480 is going to be much bigger than 10. So I know that that means, right? And then number 3, do we have large population? At least 10 times or more? Yes or no? Yeah, how many US adult, right? That uses math, right? That employees in United States, there are a lot, millions of adults that's working in United States job that uses math, right? Okay, so therefore, we know that large population. Okay, checks. So all 3 checks here. So we know that this is gonna be, right? Can normally distribute it. Now let's go to step number 1. Okay, step number 1. Let's go here, step number 1. Okay, so for MVP point, can someone identify your null and alternate hypothesis?
The null is 56%.
Good, equal to 56, right? Because it's prior. You're like, no, you haven't actually increased or decreased, whatever it is, right? Or not equal to. What's your alternate hypothesis? Here, it's highlighted.
Be less than.
Very good.
56.
Okay, Hugo gets MVP point 56. Okay, so state your null and alternate hypothesis. Null hypothesis thing, no, it hasn't changed. It's exactly the same as before. Okay, but we're trying to investigate, right? We want to figure out, is there sufficient evidence to conclude that the percentage of adults who feels basic math skills are critical to their job has decreased, right? Okay, so that's step number 1. Step number 2. Step number 2 is to identify your significance level. If they don't tell you, it's always considered to be what we call the 5% here, 0.05. Okay, but they tell you, that's your significance level, step number 2. Step number 3 is to calculate your test statistic. Test stat, which is your z-value, using the definition p hat minus p over square root of PQ over N, where this one represents RSE, okay? Standard error or new standard deviation, okay? Let's actually
Professor, what does the TS stand for?
Oh, test statistic. This represents the test.
And that's written.
And that's right here. So go all the way up here, and there we go. You notice that it's a test statistic. She just abbreviated it as a TS.
And then what you wrote after that, what is that?
Okay, that's the formula. Oh, the
So it's just
Z.
the formula?
This right here is the Z-score.
Okay.
Z-score value. Okay, your test statistic is calculating the Z-score value. Okay, so this is equal to, then let's input all the information here. P hat is 0.61875 minus P, which is 0.56 divided by square root of 0.56 times. Don't put this into a calculator. We're going to be using StatCrunch here, divided by 480. Okay, and let's actually calculate that value using our StatCrunch. Let me actually unshare here and share. You guys should all have your StatCrunches open. Okay. All right, so now go to Stat. Similar to that of confidence interval, go to population proportion, one sample, with summary. Okay. Click on this and you get this. What's the number of success here? What's your X value? What's your X value?
297.
297. What is the number of observation in this case? How many samples do we take?
480.
480. And then remember, when we're dealing with confidence interval, we clicked on this confidence interval, 95% confidence interval. Now we're doing hypothesis testing. So therefore, your p-value here is 0.56. And then we have, and we could change this right here by clicking this down. We want less than, okay? And then we want to compute, okay? The most important value that I want to highlight here is this one right here. Okay. So far, so good. Okay, and that tells me the p-value. Okay, this is 4. And then I want you to write that down, 0.9952. And other things that you could actually highlight is the standard error. Okay, that's the standard error if you wanted to figure out, which is equivalent to 0.02266 about. And then the test statistic, which is your z-stat. Okay, we don't necessarily need to know this right here, 2.593. Okay, we could write that down. Okay, everyone got this? Anyone have any question here? Okay, I'm gonna stop sharing. I'm gonna go back to my here. Okay, and this is what we got. Our p-value is 0.9952. Okay, and your test statistic is 2.593. Okay, your standard error, as you can see, is that right there. Your test stat is that. Okay, but the only thing that what we want to be concerned about is this whole thing right here, that p-value. Okay, and we're going to compare that to your significance level. And what is our significance level? 0.05, and we want to compare. And our p-value is actually what? Greater than, less than? Which one? Greater than or less than?
Greater than.
P-value is greater than our significance level. Now let's go up here. Okay, what did they tell you here? If your p-value is what? And you want to memorize this. Okay, your conclusion. If your p-value is less than, if your p-value is less than your significance level, alpha level, then what do you do? Reject null hypothesis. If your p-value is greater than your significance level, what do you do? Brooklyn, can you read that for me?
Do not reject the null hypothesis.
So which case do we have here? Brooklyn? Which case do we have here?
Do not reject.
Right, so we have p-value which is greater than their significance level. We do not reject null hypothesis. So let's go here. So we say, oh, p-value is greater than your significance level, which is your alpha level. So therefore what? Do not reject null hypothesis. Cameron, if you're not rejecting null hypothesis, are you cross out the null hypothesis or do not cross out the null hypothesis?
Don't cross it out.
Don't cross it out. Do not reject null hypothesis, which means that you're actually rejecting alternate hypothesis and accepting null hypothesis, because you're not rejecting null hypothesis, right? Okay. Do not reject null hypothesis. I'm not rejecting it, which means I'm accepting it. Okay. What's my conclusion then here? Alex, what would be my conclusion if you're not rejecting null hypothesis? Looking at this, what's my conclusion? Hugo, what's my conclusion here?
The conclusion is that the percentage of employed adults who feel basic math skills are critical to their job has not decreased.
Oh, has not decreased, has not changed, right? It's equal to, right? Has not decreased. Very good. Well put. I got to give Hugo another MVP point here, right? So that will be your conclusion here. You would say, let's say that number 5, you write at 5% significance level, the data does not I can't spell. I'm doing this. Does not provide sufficient evidence to conclude that it, what do you mean by it? The employee has decreased. The proportion has decreased. Okay. Okay. It means the employee adult who feels basic math skill are critical to their job, right? Okay. It means the proportion, the percentage. So the percentage of employee adult who feel basic math skills are critical, right, to their job, okay, has decreased. So basic, this whole thing is the it portion. Whew, I think that wraps it up. You kind of see, right? This is the whole process of going through a hypothesis testing. Okay. So far, so good. Okay. Any question? And you'll do exactly similar to that with the other ones here too. Okay, using StatCrunch. Okay. Any question? Okay. All right. Hopefully. Okay. And then please, I will upload this video, but the earlier morning video for Zoom 1, right? Try to ask Maria about the uploaded video, right? Because I did problem number 2 on that lecture. So you guys could have the problem number 2, okay? And then this afternoon, I will do the mean portion of it, of hypothesis testing. So you wanna probably watch those as well, okay? Maybe that could help you out, because if you watch it enough time, you kind of sinks in, and then you just follow it by step, okay? So far, so good?
Yeah, Professor?
Yeah.
So what happens with like the assignments for module 14? There's a few that were like technically due yesterday, but I didn't do them because I really didn't understand it until right now. So I mean, do we still turn them in?
Right. So yeah, turn them in. So do everything by today. Do as much as you can. Right. I'll take it. Long as you do it by tonight, right? It's okay. Because because by doing that, you're actually studying your exam as well. Okay.
Yeah.
Going through that.
Okay.
Okay. So far so good. Okay. And if you have any, Amanda, is there any tutoring after today or tonight as well?
Yeah, I think there's one at
Oh yeah,
1
Jason
o'clock,
has,
and
yeah.
then there's 4 o'clock today.
And there's also Jason is there tonight from 7 to 9. Okay.
Yeah.
Professor Hartman is going to be available tonight. Okay, for you to actually ask questions. Okay.
And then the Zoom lecture for 10:30, it's in the process of being uploaded. So look for it in a couple of hours. Okay, guys?
Okay. Great. Thank you. Okay. All right. I'll see you guys next time. Right. Good luck with your exams tomorrow. Right. Okay. Hope you guys do all well. Right. Do your best, because if you get, I think 75% or above, you could actually replace your lower score exam with this one right here. Okay. So try your best from now. Just work your butt off all night tonight. Okay. Don't do an all-nighter because you need a lot of sleep to be fresh. But study all day today. Okay. All right.
Thank you, Professor.
I'll see you guys. Okay.
Thank you.
All right. So I'm gonna make Amanda host today.
Luis host, please.
Okay. So Luis host today. Okay. And then I'm gonna leave.
All right. So we're just gonna finish a couple of the other ones. So I'm gonna go ahead and share my screen. Professor Yi went above and beyond with his work on his. All we really needed to do was collect all the information given in the problem and identify the variables, which he did. Set up both the null and alternative hypothesis, which he did as well. And check the requirements for the COT and decide which distribution will be used to find the p-value. That's all you really needed to do for these two. But Professor Yi went a little bit above and beyond. He went ahead and solved it for you guys as well. We'll solve one of them for you. Okay, but that's all we really need to do for these two sections of the class or portions of the homework. I believe for this module, it's learning how to set things up. For the next module, it should be how to solve things. All right. So I'm gonna go ahead and get into those. I believe you guys did this one, right? Yeah. So again, we should be working with our, we should be following these steps. So the steps from the previous thing where we collect all the information, we set up the null alternative, and we check the COT requirements. Okay, so let's go ahead and do that for the first one. I'm pretty sure he skipped the first one. So first, write what is, I like to highlight anything that's important. So I'm gonna go ahead and read it and highlight anything that I deem that is important. In a survey conducted by the Gallup organization in October 2013, 320 of 500 teenagers said they favor life imprisonment instead of the death penalty. Suppose that we read that 47% of teenagers prefer life imprisonment. If there's is there significant evidence to support the claim that a higher proportion of teenagers today support life imprisonment at a 0.1 level of significance? All right. So let's go ahead and write anything that is known. Okay, so what do we know? Well, we know P, right? Since we're talking about proportions, we should know P. What is P in this case? Okay. P is the population. Oh, sorry.
0.47?
0.47, because we're talking, that's the population proportion. 0.47. So then what is P hat gonna be? What is the sample proportion?
320 over 500.
320 over 500. So that would just be 320 divided by 500. So that's just going to be 0.64. (320/500), which is equal to 0.64. We also know we have a significance level, an alpha of 0.01, I mean 0.1. What else do we know that's important? It looks like we could find Q and Q hat, but I don't think we really, do we need them? Yeah, I think we'll need Q and Q hat. So what is Q equal to? In this case, it's just 1 minus P, P being 0.47, so Q is equal to 0.53. So then Q hat has to equal 1 minus P hat. So then what is Q hat? That's just 1 minus 0.64. And that's 0.36. Okay. I think that's all I could get. I'm not so sure if I have anything else. Oh, we also have a sample size. What's our sample size?
500.
500.
500, yeah.
Thank you. Is there anything else we could get? That's pretty much it. I don't see anything else that we could get. So that'll be the first part you'll do, getting all your variables. As you can see, collect all the information given in the problem and identify the variables. We just did that. We found the knowns. Now what we need to do is we have to set up both the null and alternative hypothesis. Okay, so let's go ahead and set that up. We're dealing with proportions, right? P. So we're gonna set that up. So H null, and we're gonna do with P. What is P equal to? Well, we already stated P is equal to 0.47, right? So then what is the alternative equal to? And this is where you need to look out for keywords. Keywords in this case will be higher than. Okay, y'all just, keywords will be higher than, lower than, less than, more than, different, change, so forth and so on. Any words like that, that's the keywords you're looking for. In this case, the keyword right here says claims that a higher proportion of teenagers today support life imprisonment. Since we're talking about a higher proportion, that means greater than 0.47. Okay? So we have this. All right. And that's all we have to do for the second part. Oh, wrong thing. Now we just need to check the requirements of the central limit theorem to decide which distribution will be used to find the p-value. Okay, let's go ahead and do the CLT requirements. So I'll put it down here. CLT. Let me change colors. CLT. What's the first requirement? Anybody? What's the first requirement for proportions?
Simple random sample.
Simple random sample. Is it simple random or just random?
No.
It doesn't really say anything about being random, right? Let's see. In a survey conducted by the Gallup organization in October 2013, 320 of 500 teenagers said they favored life imprisonment instead of the death penalty. Suppose we read. So it doesn't really say anything about simple random sample. But just for this case, let's just suppose it is SRS. Okay? Let's just suppose it's that. Let's continue with the requirements. What's the second requirement for proportions? Remember, NP has to be greater than what?
Ten.
Yeah, and then Q has to be greater than 10 as well. So if we plug in our numbers, N is equal to 500, and P will be equal to 0.47. And then N, again, 500 times Q, which is 0.53. Would both of them be greater than 10? This one gives you 235, which is greater than 10. And that one gives you 265, which again is greater than 10. So the second requirement is met. Now the last requirement. Anybody else remember the last requirement? This is a large population, right? Which is what?
10 times the sample size?
10 times the sample size. Has to be greater than, oh, no, wait. Yeah, has to be greater than, no, give me a second. Wrong format, but you're correct. The population size has to be greater than 10 times the sample size. There we go. What's our population size? Do they give us one? No, right? They don't give us an N, a big N, right? But since little n is 500, 10 times 500 is 5,000. Is there more than 5,000 teenagers in the world? Yeah, right? There's more than 5,000 teenagers in California. At least that's what I know. There's going to be more than 5,000 teenagers in the world. So this one is true. Your population, which is the overall population of teenagers, is greater than 5,000. So besides the first one, all of them are true. We're just assuming the first one is true. Okay? And that's all you really need to do. You don't have to do anything else. You do have to set up the distribution, which will be, in this case, P hat follows a distribution of P, and that will be your significance error. Okay? That's all you have to set up on your own. You fill in P, you fill in the significance error. But other than that, that's all they want you to do for this case. They want you to find what you know about. They want you to do your hypothesis test, and they want you to do the central limit theorem. Okay? Any questions on this one? Solving it will be for later on. Like I stated, Professor Yi went above and beyond. He solved the other ones for you, but for solving them, that will be till later on. Right now, we're just setting things up till we are able to solve. Okay? So
wait, so on the test, we won't have to solve, just do this?
If it doesn't say solve, then I don't think so. For the most part, it looks like you don't need to solve anything. If you take a look at the module 14, unless they throw module 15 today, then no, you don't. But let's see. I wasn't able to watch the whole video, so check this one first, because I could be wrong. Okay? Check the video first, but just for this homework, they just want you to set things up. Okay? They don't want you to solve them, at least now from what I understand. Okay? But I can't say for sure that they want you to solve it on the exam. Check this one right here, the video.
Okay.
Because that one will tell you what you're gonna be doing. But other than that, everything else, if you look at the homework, I have the homework up on here. Let me see. If you look at the homework, it just says set things up, set up for hypothesis. You do not need to solve these problems. The next one was analyzing hypothesis. This, they already give it to you. You don't set it up. All you have to do is analyze, set your hypothesis, and interpret the p-value. And I'll get to that in the last 15 minutes of class. Okay? But for the most part, just set things up. All right, we'll do one from 8.3, hypothesis test for population mean, and then we'll go ahead to analyzing hypothesis test. Okay, everything is pretty much the exact same thing, except your test statistics is different and your standard error is different as well. Okay, but other than that, pretty much you're gonna do the exact same thing and solve it. Not solve it, set it up. So let's see. Example 1. According to the United States, mint quarter weighs 5.6 grams. A researcher is interested in determining whether the state quarters have a weight that is different from 5.6 grams. He randomly selects 18 quarters, weighs them, and obtains the following data. He got all these weights. At alpha equals 0.001 level of significance, determine the p-value and use it to decide if there is evidence to conclude the state quarters have a weight different than 5.67 grams. Okay, so what we're going to do is we're going to state the knowns. Let's go ahead and, well, first, let me go ahead and highlight important stuff. All right, so let's state what is known. Well, what do we know? We're talking about means, right? This one, we're going to be using means. We're not going to be using proportions or anything like that. We're going to be using means. So what's the mean weight of the quarters? That's just going to be 5.67 grams, which is the top one right here. Okay. Now, they don't give us a standard deviation. That's fine. We don't really care for standard deviation because we're talking about means. Okay. Well, for this. Now, they also give us that he randomly selects 18 quarters. If he randomly selects 18 quarters, that's our what? Our sample size. Okay. And weighs them to obtain the following data. Let's see, what else? He randomly selects these 18 quarters. We also have the significance level, which is alpha, 0.01. And we could also get the sample mean. How do we get the sample mean? You add all of these up and divide by 18. I'm not going to go ahead and do it. I must just see if I could get the answer because that's going to take quite a while. All right, so give me a second. Which one is it? Sample mean is 5.702 grams. I'm pretty sure everybody knows how to get that. You could use StatCrunch for that. You could also use what do you call it? You could also use StatCrunch to get the standard deviation as well. So I'm gonna go ahead and write down the sample mean and the and the standard deviation. All right, so let's go ahead and write that. Like I stated before, where was it? I kind of lost my page. Sorry. All right. X bar, which is the sample mean, is equal to, I'll share my screen right now, 5.702. And then the sample standard deviation is equal to 0.050. Okay. And that's going to be it. Okay, as you can see, I have my X bar, sample mean, and our S. Like I stated, if you want to get the sample mean, plug this into StatCrunch, get the summary stats, and you'll be able to get your sample mean and your sample standard deviation. So that's it for the first part. We only want what's known. Now what we need to do is set up our hypothesis testing. Okay. So let's do H no. What is H no? That's just the mean is equal to 5.67, right? So then anybody want to tell me what's the alternative? What's the key word in what I highlighted?
Different,
Different. What does different means?
not equal to.
Not equal to. Everybody understand that? Different is not saying less than, is not saying, it's not saying greater than or less than. It just wants something that's not this. There's also a lot of students confuse that with, well, a lot of students just tend to forget about not equal to. So make sure you don't forget about that. That exists. So that will be 5.67. And that's your second part. You're just setting up the no and the alternative. The last thing we need to do is check our CLT, central limit theorem requirements. Okay. First, what's the first requirement? Anybody? And this is the requirements for sample means. So what's the first requirement? It's the same for proportion. It has to be random, right? Or SRS. Is it random? Yeah, it's circled. I circled it right here, right? He randomly selects whatever, however many quarters. So the first one is met. The second one, what's the second one for means? Anybody remember?
Sample size greater than or equal to 25.
Sample size greater than or equal to 25. Is that true? Is our sample size greater than or equal to 25?
No.
No. But I'm gonna cross that out. That one doesn't work. There's another requirement for number 2. Or it comes from a normal population. Okay. And that's gonna be true. Or we're gonna assume that's true in this case. Now the last part is the same thing as previous. Big N has to be greater than 10 times little n. So what is big N? This would be 180. Is this true? Is our population size greater than 180? Is there more than 180 quarters in the world? Yeah, that's true, right? No one is, there's more than 180 quarters in the world. That's not something that's false. You could go to a bank and they'll probably have a lot of quarters. So this one is true.
Lisa, how do you know if it's a normal population?
Usually they'll tell you. They'll say normal distribution or something like that. But in this case, they don't really tell you. We're just gonna assume it's true. Or if you wanna, let's see. Yeah, in this case, we're just gonna assume it's true. All right. It usually tells you. I'm not so sure why it should have been there, but usually they say something about a normal distribution.
Or I guess if you look at the data set, no?
Yeah.
Kind of looks normal.
Yeah, I think if you probably even plug this in, you'll get something normally. But I think we're talking about the population though, not the sample. But yeah. Other than that, that's really pretty much it. You don't need to do anything else. You just set that up. and you should be fine for this. You, like I stated, you only want what's known. You set up your hypothesis and do the central limit theorem requirements. Okay. So I'm gonna go ahead and move forward to the next ones. You guys could do these, the practice one on your own. And I'll go ahead and get started on the analyzing hypothesis test. So this one, they give you the answers for them. You have this with you, okay? You have, this should be available to you. So these are the answers for the analyzing hypothesis test, okay? But the problem that most of you might have is interpreting your p-value, which is the part I circled. Okay, and I'm gonna go ahead and help you out and give you a list of what you need to do. But other than that, you guys should start working on, or if you don't know how to do or set up your hypothesis, you should work on this one. Oh, not that one. This was tell you how to set up, or this will give you examples on how to set up your hypothesis. Okay, if you don't know how to set up the hypothesis, you should work on that one first before you work on this one. And it also wants you to do, let's see. It also wants you to interpret the p-value, which I'm gonna show you, and write a conclusion for the problem. And for the conclusion, it's a little bit easier than the p-value interpretation. So let's go get in here and start working. Okay. So in 2002, the mean age of an inmate on death row was 40.7 years. According to the data from the U.S. Department of Justice, a sociologist wondered whether the mean age of death row inmates has changed since then. She randomly selects 32 death row inmates and finds that their mean age is 38.9 years, with a standard deviation of 9.6. Has the mean age changed significantly since 2002? And I'm hiding the p-value as well. Okay, so I'm not gonna write the whole thing down because it takes a while, but I'm just gonna go off the answers. Okay, so we're gonna set up our hypothesis test. We're talking about means, which is why they have a mu. The mu is equal to 40.7 as stated right here. Okay, and the key word in this case is has it changed? Has it changed does not mean is it less than or greater than. It means is it different? Is it something else? So that's why they have a not equal to signs here. Okay, so this you should this first part you guys should understand. So now for the tricky part. I'm gonna go ahead and give you a format that you probably should be using, or a list. So this is, I'm gonna call this a p-value interpretation. I'm gonna call it INT because I want to spell the whole thing out. So let's go ahead and read and highlight the important things in the p-value interpretation. Assuming the population mean for inmates on death row is 40.7 years, the probability of getting a sample of 32 inmates with a mean age of 38.9 or more extreme is 29.7%. Okay, so let's break this down. The first thing you want to be writing is assumption, or if, an if statement or an assume statement. So assume, did I even spell that right? Assume the null hypothesis, H is true, okay? So I'm gonna go ahead and highlight what I'm talking about. So the first thing you wanna write down is assume that part is true. Assume that the population mean, which is right here, the population mean, for death rows is 40.7 years, okay? That's the first thing you wanna write down in your p-value interpretation. assume that the null hypothesis is true. Okay? And that will give you your first sentence. The second thing you want to write is your sample size. Okay, before that, the probability of your sample size and sample, and this is going to be different. This is going to either be your mean, your proportion, or your standard deviation. So this, it depends on the question. Okay, so let's go ahead and read what I'm talking about. The probability, I'll do it in a different color actually. The probability of getting a sample size, so this is your sample size, of 32 inmates with the sample mean of 38.9. So that's the second thing you write, okay? The probability of your sample size is 32 inmates with a mean age of 38.9 years, sample mean. And then the last thing you want to write, so I'll write this in purple, is your alternative sign. So what I mean by that is this part right here. So let me highlight it. So depending on the sign, that's going to change. So right here, they put more extreme. The reason they put more extreme is it could be extreme on the right side or extreme on the left side. So it could be bigger or it could be smaller. It didn't specify. It didn't say it's bigger than or it's less than. It just said it's going to be an extreme value. We don't know whether it's bigger or less than. It's just extreme. So that'll be your alternative sign. And I forgot one thing actually. P-value. Your p-value is this part right here. Where does the p-value come from? Well, that's just right here. They give it to you. You don't have to be looking for it. Okay? So the p-value is given to you right here. Using these steps, you should be able to write down your p interpretation for each and every one of them. Okay? So let's take a look at the second part. I won't give you, we are running out of time, so let's just kind of evaluate this one now. Oops. And let's break it down. So I'm gonna put this one in red. Okay. So let's go ahead and highlight the important parts. So this is for number one. Assume the null hypothesis is true. If, in this case, they use if, not assuming, that's still fine. If the population proportion of pet owners who talk to their pets is 37%, that's your null. If P is equal to 0.37, but write it in words and assume it's true, okay? If the population proportion of pet owners who talk to their pets on their phone is 37%. All right, so now let's move on to number two. The probability of a random sample, which right there, your sample size, pet owners who will have 54, and that will be your sample proportion, 54 out of 150. That's what the problem said. Or more owners who speak to their pets, and right here, I'm not 100% sure if this is a typo, but I think this should have been less. Who speak on to, or more owners who speak to their pet. Wait, actually, give me a second. Let me change colors. Or more owners. And right here, what I highlighted in purple will be your alternative sign and your p-value. So again, I'm not so sure if that was a typo. I think it should have been less than. Let's see, then the probability that are, yeah, I think that one should have been less than, because we have an alternative sign of less than, or less, owners who speak to their pets on their phone is 0.3999. Okay, so like I stated, using these guidelines, you'll be able to do the p-value interpretation. Assume the null hypothesis is true, state your probability, and then write your alternative side with your p-value. Okay, you're gonna find this format to be the same thing in the rest of them. All right, so know how to do the p-value interpretation. That's gonna be important. Other than that, your conclusion, you're gonna state whether there's sufficient evidence or insufficient evidence that to claim that the null hypothesis. You're just gonna say, are we rejecting or not rejecting the null hypothesis? And again, that depends on your p-value. If your p-value is high, then we fail to reject. If your p-value is low, so like this case probably, then we reject. And that's just the conclusion. But other than that, that's pretty much it for today. I try to get as much in as possible for you guys to understand. I'm gonna leave this on screen for a while. Make sure you guys copy this down. This will help you with your p-value interpretation. Don't take that for granted. Don't just look at your answers and move along. Okay. We also
Put the
need
spins in the chat too. Okay.
All right, thank you. Last thing we're gonna do is we're gonna do the what are these called? The MVP points. Sorry. All right, so let's go ahead and get this out. All right, so it says Brooklyn has 1 spin. All right. She gets 1 point. Cameron has 1 spin. He gets 2 points. Hugo has 3 spins. He gets 10 points. And Jacob has 1 spin. And he gets 1 point. All right. Other than that, that's it for today. Have a nice day. Make sure all of you get into some tutoring. If you guys need help with this module, get your tutoring done so you'll be able to work on your exam tomorrow and pass it. All right? Or have a nice day and goodbye.
Thank you.